I am Jaini Javeri, and as a part of my midterm project for the Architecture 653 course, I have chosen Marina Bay Sands as a model. Uh, so in my model, I have three towers, and all these three towers are connected on the top with a sky park, which is in shape of a boat or a aeroplane. Um, um, each of the towers is has three components. That is, one is the front slab, one is the back slab, and then both these slabs are connected by an elevator shaft in between, which is over here. Um, everything these two slabs connect at the 23rd level, and below that you can see there is an opening in all the towers. Everything in the model can be pretty much parametrically controlled. We can change the thickness of the front slab, we can change the thickness of the back slab. We can also change the shaft thickness, and we can also change the openings in the tower as we want. We can see that when you change the opening in tower 1, the opening in tower 2 and 3 update automatically. So let us see how all these changes are applied to the model. So everything is like parametrically controlled. For my curtain panel design, I chose normal rectangular curtain panels, and as it is on the Marina Bay Sands. To give a sense of uniformity to my panels, I chose to rotate the panels such that they stay vertical. That is, they are at 90 degrees with respect to the ground, no matter on which curved surface they are lying. So let us see how I started creating my panel. So I created a rectangular shade with two parameters of width and thickness. This shade was then imported into my rectangular curtain panel model, and here it was placed on two reference points, as you can see here on the boundary, and this gave me an opportunity to use the inclination of this reference plane to rotate my shade, and hence I could rotate the shade. So let us see how. So if I make it 0, it will become okay, and we can see how these reference planes also change. The other important fact is to link the width of this panel with the width of the curtain panel, and this will ensure that whenever the rotation is 90 degrees, the shade closes the panel completely. The one important thing in this is to keep the width of to keep the width as an instance reporting parameter, so that whenever you import this into a family, then it will update according to the divisions which are made, and you don't have to update it all the time. And let us see, when I import this into my mass model, how I can see the inclinations. So here I can see that when I import this, each of my panel is like almost vertical with the ground, and the angle of this is linked to the inclination of the tower 3, and hence if my opening size changes, then my inclination of the tower 3 changes, and hence does this panel change. So it helps to parametrically control this. This was then imported into a project, and floors and roofs and walls were made into this, and to create a final project. Thank you for watching this, and hope you have a nice day.